Hi guys, thanks for joining me virtually. I'm an undergraduate wildlife ecology student at the University of Wisconsin-Stevens Point, and I'm excited to share with you guys the research I've been doing on the impact that local scale mass production has on bait site use by black bears in Wisconsin. And we're also going to cover some of the implications this could have on human bear conflict in Wisconsin. First, I'll introduce you guys to a little bit more about bear hunting in Wisconsin in general. Beginning in the 1950s, black bear harvest rates have just steadily increased, and the state currently offers a lot of good bear hunting opportunities. In the fall of 2020, there are about 24,000 black bears, so the state has a very large and robust bear population. And for the 2020 harvest season, they issued about 11,500 permits with the goal of harvesting about 3,500 bears. So Wisconsin does harvest quite a few bears. And that pie chart shows us that at least 75% of bears that were harvested in 2019 were harvested using at least some amount of bait. So that means that baiting is by far and away the most popular way to harvest a bear in Wisconsin. But when you manage for such a large bear population, that definitely comes with its drawbacks. Agricultural damage and nuisance bears, as well as bear property damage, are all present in Wisconsin. What that bar graph on the bottom shows us is the number of bear complaints in Wisconsin from 2010 to 2018. The TA stands for bear complaints that were handled using just technical assistance or a DNR staff just coming in and giving advice on how to have the complainant handle the situation. And then DC stands for complaints that were handled using direct intervention like lethal removal or translocations. And even though it looks like the amount of complaints is kind of flattened out in recent years at about 600 complaints, bear human conflict is still a pretty big problem in Wisconsin. And so the way that Wisconsin manages its bears is in large part due to the social carrying capacity. How many bears are people willing to tolerate in their area? And because there are a lot of people that are financially affected by bears, but people also enjoy having bears around as both a hunting game animal as well as just for wildlife viewing. And the recent restructuring of the bear management zones is a good example about how the Wisconsin DNR manages black bears with social carrying capacity in mind. It used to be that we had a large southern zone called Zone C, and we recently broke that up into zones C, E, and F because the Wisconsin black bear population is continually expanding southward, especially along that Mississippi River corridor. So Zone E gives the Wisconsin DNR a lot more ability to more fine tune their management of bears in southern Wisconsin. And in Zone F, there's just too many roads, too many cities, too much agriculture, and it's not a good place for bears to be. So that has managed to have no bears in Zone F. And Zones A and D were restructured to give the DNR more fine-tuned control over the bear damage that was occurring up there because there was a lot of bear damage on corn crops up in northwest Wisconsin. So you can see that we manage bears with social carrying capacity in mind in pretty much everything that we do. So the objective of my study was to determine the relationship between bait site use by bears and hard mass production. But you can also substitute in different human resources for bait site use, for a bait. For example, like trash, you could think about it as determine the relationship between bears' use of trash and hard mass production, because both of these things will affect how we might decide to manage bears in Wisconsin. How does hard mass production influence human bear conflict, and how does it influence their use of bait sites? And previous research in other areas has shown that when acorn production is low, that increases the amount of human bear conflict. For example, in Japan, they found that during a beech crop failure, the number of nuisance bears that were killed increased. And then inside of Colorado, they found that bears were more likely to use urban areas when there was a hard crop failure. And that was found once again in Colorado, but also in Utah. And then on the bear harvest side of things, research in other states like Minnesota, West Virginia, and inside of Smoky Mountain National Park have found a negative relationship between bait site use by bears or hunter success and the amount of hard mass production in the area. So, if research in different states and countries have found these relationships between hard mast and either human bear conflict or bait site used by bears, why would we need to do something similar in Wisconsin? The thing that makes Wisconsin unique is that it has a comparatively long baiting season when compared to other states that harvest bears. Wisconsin also has a unique variety of hunting methods because Wisconsin allows both hounds and baiting, while some states might only allow one or the other, or maybe they only allow fair chase. Wisconsin also has an expanding bear population. As we covered previously with those bear management zones, the bear population is expanding southward, and that opens a door for more human bear conflict. So it's important to see if the relationships found between hard mass production and human bear conflict or bait site use is the same in Wisconsin as it was in other areas, because as you can see, Wisconsin is very unique. And so what I did is I maintained 10 bait sites from August 3rd to October 2nd. There were 5 up there in Lincoln County and 5 in Marathon County, and they were all placed on public land. And each bait site had a trail camera in order to determine the amount of bear attendance. And when calculating bear attendance, we simply took the number of hours a bear was present, divided that by the number of hours we baited, and that's how we got the proportion of time that bears were present or bear attendance. And before we get any further, it's important to mention we had to remove 2 bait sites from analyses because one camera was stolen and one was damaged. I guess that's just the reality of field work. And then what this bar graph on the right shows us is the bear attendance scores for each one of the bait sites. The M represents the Marathon County bait sites, and the L represents the Lincoln County bait sites. And what's the key takeaway from this graph is that Lincoln has much more bear attendance than Marathon. So remember that for later because that will become really important when we start getting into the rest of the analysis. And when determining the amount of acorn availability around the sites, we had 10 survey locations in each county. At each one of those locations, we would determine how dominant oaks were on a scale of 1 to 4. And then we would take measurements of acorn abundance on a scale of 1 to 4. And when we multiplied those two together, we got our mast index for each location. But before we get any further into the analyses, it's important to think about, how are these bears deciding to visit the bait sites? So if we imagine that this whole screen is this bear's home range, and it managed to find its way to our bait site and it's just enjoying itself, eating some cookies. And that red line represents how far that bear can move in a single day. It's possible this bear was just moving through its home range. It noticed that, hey, I can get to that bait site within a day. And it considered the acorns that were available immediately around it. And it decided it's not worth its time or its energy to go and look for acorns. There's just not enough of them. So the bear decided it was worth the risk to go to that bait site, risk an interaction with a human being, and go to that food resource that it knows it's there. But it's also possible this bear was somewhere else in its home range. And it considered both the acorns immediately around it, as well as across its entire home range, because we know bears have a very good memory of where different food resources occur at different times and spaces. So this bear probably considered the acorns across its whole home range, and it decided it's not worthwhile going to look for acorns. I'm just going to lose energy. I'm not going to gain anything. And it decided, I know where that bait site is. I'd rather go where I know there's food, even if it's risky. So what if that bear decided to move to that bait site? But it's important to remember that even though we're talking about bait here, you can also imagine this as some other human resource. It could be trash, it could be bird feed, but bears are probably thinking about visiting these other human resources the same way that they're thinking about visiting bait sites, which is just another artificial food for bears. And we didn't know whether bears were thinking about visiting the bait sites on a smaller scale, like a daily movement scale, or a home range scale. And that's why when calculating acorn availability, we had 3 different scales. Our first is the daily movement scale, 3.4 kilometers, or how far a Wisconsin bear moves on average in a day. And then we had the maximum female and male home range scales. And this is what those three scales look like when mapped out over our 10 bait sites, with Marathon bait sites on the left and Lincoln bait sites on the right. Those red triangles represent the locations of the bait, and the blue circles represent the daily movement scale, pink the female home range scale, and purple the male home range scale. Those green pixels are the hard mass producing cover types within those scales, and the red X's represent the bait sites that had to be removed. So we're going to take that hard mass producing cover type into the next part of our analyses. What we did is we calculated the percentage of hard mass producing cover type in each one of those scales for each bait site, and we did that using the WISC-LAN2 dataset on ArcGIS Pro. And then we multiplied that hard mass producing cover type percentage by the mast index to get a hard mass availability score for each site at each scale. This bar graph on the right shows us the hard mass availability score for each site at the daily movement scale. And what's really interesting here is that we see the exact opposite of the pattern that we saw with bear attendance. Because before, Lincoln had much more bear attendance than Marathon, whereas now Marathon has much more hard mass than Lincoln does. What we then did is we graphed the amount of bear attendance for each site against the hard mass score for each site, and we did that for the three different ranges. You can see that there's a negative relationship between bear attendance and hard mass at the male home range scale. The R-squared value represents how much variation in bear attendance can be explained by the hard mass score. So an R-squared value of 1 would mean a very strong relationship between the two, and an R-squared value of 0 would mean no relationship between the two. So an R-squared value of 0.36 is actually fairly weak for the male home range scale. What's really interesting is that as we decrease the size of our scale, that R-squared value becomes bigger and the relationship becomes stronger. So we had an R-squared value of around 0.51 for the female scale, and an R-squared value of 0.98 for the daily movement scale. So this indicates a very strong exponential decay relationship between bear attendance and hard mass at the daily movement scale. And what this might mean is that bears are deciding to visit bait sites and/or human resources in general at a smaller scale. They're considering resources immediately available to them rather than across their entire home range. What's also interesting is that it looks like there's a threshold to hard mass availability where bears simply stop visiting the bait sites. What this could mean is that if you have a neighborhood surrounded by a hard mass producing forest, if your hard mass availability score is above a 1, that might mean that the bears in your area have enough natural food that they don't feel tempted to go into your neighborhood, and that means less negative bear interactions. And that might also mean that if your hard mass score is under 1 in that scenario, that might mean you have more bears coming into your neighborhood because there's just not enough natural food for them to meet their needs. So what are some possible implications of this research? First, it would seem that Wisconsin bear hunters will probably be more successful during acorn crop failures because the less natural food there is for the bears, the more likely they are to take risks and go to bait sites, and that means more opportunities for hunters to harvest a bear. On the flip side of that coin, this probably means that there will be more human bear conflict during hard mass crop failures because the less natural food for bears, the more likely they are to take a risk to go into a neighborhood and look for other sources of food, like your bird feeder or your trash can. We might see an increase in bait hunter success during acorn crop failures, but we might not see a similar trend with hound hunters because if you think about it, hound hunters aren't really depending upon a bear to visit a bait site in order to have a successful hunt. And finally, we hope that the results of this study can be used to better predict hunter success and inform damage management in the future. If we imagine that we're trying to decide how many permits should we issue for the upcoming bear season, if we can predict, how good will the acorn crop be this year? If we know it will be a good acorn crop year, then we would expect bear hunter success to be lower And that might mean we need to issue a few more bear permits in order to meet our management goals. And if we don't meet our management goals, if we don't harvest enough bears and we have a higher bear population than we intended, that could lead to an increase in the number of human bear conflicts, which could decrease people's tolerance for bears and permanently decrease our social carrying capacity. And I'm currently working on figuring out what different variables might also affect a bear's likelihood to visit a bait site. This includes things like precipitation, temperature, proximity to agriculture. And I'm going to examine this using a global linear model to try and piece out which variables are actually having an effect on a bear's likelihood to visit a site, and what data do we need to collect in order to be able to predict a bear's likelihood to visit a bait site. And there are a lot of areas for future research. First one being, how does hard mass production influence human bear conflict? We've looked at it indirectly with this study, but it would be worthwhile looking at what is the direct relationship between the two. If you're in a neighborhood and you have hard mass producing forest around you, would that increase or decrease human bear conflict? Maybe it would increase human bear conflict because bears are attracted to that forest. And then during a poor acorn crop year, the acorns that they usually depend upon are no longer there. And now they need to go into that neighborhood to find more food resources. Or maybe it's that having hard mass producing forests around a neighborhood would decrease bear human conflict because there's more natural food for them. So they have less reason to go into the neighborhood to look for food. And I think it's also important to look at what different landscape level characteristics can be used to predict where bear damage and conflict will occur. If we can figure out what different landscape factors can be used to predict bear damage, then we can look for hotspots in Wisconsin, and that could increase the efficiency of our bear damage management and just make us better managers in general. And that brings us to the end of my talk. I would like to thank the Doug Stevens Boone and Crockett Wildlife Research Fellowship for funding this research. And I would like to thank Dr. Katie Sartini and Nathan Klug for their help throughout this entire process. And I would like to thank you guys for staying and listening. Thank you.